some of the main elements in the human body. Oxygen, carbon, hydrogen, nitrogen, calcium. And I see here how much we have in the human body. But it raises this question. I know that water is H2O. And I know that the human body is made up of around 70% water. So the human body, 70% water. Water is H2O. That means I've got an H connected to an oxygen, connected to another hydrogen, like that. That just seems strange to me, because I have two H's, one O. So two hydrogens, one oxygen. If I have two hydrogens and one oxygen, how is it that oxygen is 65%, hydrogen is way down here at 9%? Because most of my body is made up of water, H2O, and I have two hydrogens for every one oxygen. How is it that oxygen is 65% of my body and hydrogen is down here at 9? So that might be kind of puzzling until I look a little closer at the chart. Approximate percentage of the human body by weight. So that's key. Why is that key? Well, because the atomic weight of oxygen is 16. The atomic weight of hydrogen is 1. So which one weighs more? Well, oxygen weighs 16 times as much. So if I were to count the individual atoms, my body would have way more atoms of hydrogen. But when I'm looking at it by weight, each molecule or each atom of oxygen weighs 16 times as much as the hydrogen. So looking at it by weight, oxygen way up there, whereas hydrogen, I have a lot of it, but just doesn't weigh nearly as much. I mentioned earlier hydrogen is important to the human body because of the way it bonds. Atoms will bond together for stability. Those outer energy levels need to be full for the atom to be stable. 2 in the first energy level, 8 in the second energy level. They need that stability. So what will happen is those atoms, whenever they're unstable, whenever there's open spaces in those energy levels, they will try to fill it with an electron from somewhere. Usually it's from another similar atom. They'll just share it. And those are called covalent bonds. Sometimes, though, the atom will either gain an electron from another atom or give their electron to another atom. And when they do, that's called an ionic bond because they're making an ion. They're either gaining or losing an electron to get either a positive or negative charge. And that creates what's called an ionic bond. Covalent means they're sharing the valence electrons. The outer electrons are being shared so that they can be stable. So let's look at an example of some chemical bonding. So here I have an atom of sodium. 11 protons. To be neutral, 11 electrons. 1, 2 in the first energy level is full. 3, 4, 5, 6, 7, 8, 9, 10. That's 8 in the second energy level. It's full. Now I've got this 11th electron in the third energy level. So sodium has 1 electron. It needs 8 to have that energy level full and stable. It has 1. It needs 8. That's a pretty unstable element. Chlorine has 17 protons, which means it also has 17 electrons. 2 in the first energy level, 8 in the second energy level, that makes 10. 7 in the third energy level. So chlorine is thinking, I just need 1 electron to be stable. Sodium is thinking, I just need to get rid of 1 to be stable. If I could just get 1 electron, I'd be stable. If I could just get rid of this electron, I'd be stable. Where can I find an electron to be stable? How can I get rid of an electron to be stable. You want to get rid of an electron? I want to get rid of an electron. I would love to have an electron. Great, take it. So sodium gives up its electron so that chlorine will have 8 in its outer energy level and sodium will have 8 in its outer energy level. That creates a sodium ion, a positive charge, because it's given away a negative electron. Chlorine is negative now because it's taken on an extra negative electron. That electron's attracted to this large nucleus with all those positive charges. And it creates something new. Sodium is a very reactive metal. Chlorine is a poisonous gas. But together, they make something we all love. Oxygen needs 8 electrons in the outer energy level. So here, the oxygen atoms are just going to share their electrons. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. You're like, well, wait, Professor. You just counted those electrons twice. That's true because they're sharing it. This oxygen is sharing those electrons. This oxygen is sharing those electrons. So it counts for both. Both are stable. This is a much stronger bond than the ionic bonds. It's a covalent bond where they're just sharing the electrons in the outer energy level. A compound then is when we have 2 different atoms joined together and the characteristics are completely different. When the 2 atoms are separate, they're one thing. When they're joined together, they're something completely different. That makes a compound. Molecules are just atoms joined together. All right, so a definition for a molecule is just atoms joined together. A definition for a compound are different atoms joined together, and the traits are different once they're joined. So carbon is one thing, hydrogen is another. But together to make methane, it's completely different. Here we just have 2 hydrogens sharing their electrons in a covalent bond. That's a hydrogen molecule. So it's just atoms sharing electrons makes a molecule. So let's build some molecules. All right, so let's build some. So for example, if I take hydrogen and oxygen, I can get water. I can take some hydrogen and carbon, I can get methane gas. I can take oxygen and carbon and get carbon dioxide. I can take chlorine and hydrogen and get some hydrogen chloride. I can take nitrogen and chlorine and they don't bond together at all. So let's ask, is water a molecule, compound, both, or neither? In this case, water is both. Different elements together make something completely different. Oxygen here, hydrogen here, but together they make something totally different, water. And they're different elements, hydrogen and oxygen. Nitrogen has an atomic number of 7. How many protons and electrons? So if the atomic number is 7, that is the number of protons. If it has 7 positives, that means it must have 7 negatives to be neutral. We also know that the atomic weight is 14. So 7 protons plus 7 neutrons is 14. Which 2 atoms are useful for fluid balance? Mostly sodium and chlorine, the table salt that we typically eat. Very useful for fluid balance. How much of the body is made up of water? Between 67 and 70%. So let's look at the role of water in the body. If most of the body is made up of water, 67 to 70%, then our bodies are going to have a lot of traits that water has, a lot of the characteristics of water. For example, water has a very high heat capacity. That means that it takes a long time to heat up and a long time to cool down. It can absorb a lot of heat before the temperature starts to change. Our body is the same way. We can be outside in the hot weather, it doesn't change our body temperature very easily. We can be outside in the cold weather, our body temperature stays pretty much the same, 98.6, because water has a high heat capacity. So how does that water work to maintain our body temperature? One way is because water has a high vaporization temperature. That means when water, the liquid, turns into a vapor, it takes a lot of heat energy with it. So when we sweat and our bodies are covered with sweat, we've been working out and running and exercising, our bodies are all sweaty. When that sweat evaporates, it takes a lot of that heat with it, which helps keep our body nice and cool. So water works hard to maintain our body temperature. In the wintertime, it takes a long time for a pond to freeze. You might be waiting to go ice skating because the pond water hasn't frozen yet. Our body, since it's made of water, again, takes a long time to cool down. So our body doesn't get cold super quick. And water is the body's chief solvent. That means that it dissolves things. So we eat certain things, water helps to break it down. Water helps breaking down those chemical bonds, a solvent. So we put things into our body, the water in our body helps to break those things down into chemicals that we can use. All right, so life depends on water. How does water help the body maintain homeostasis or stay the same? Homeostasis just means like keeping the body the same. Well, by taking on some of the characteristics of water, namely high heat capacity, high vaporization temperature, maintaining the body temperature, a solvent, dissolving things.